In this video, I will show you how to solve a system of conic sections. We are looking at a parabola and a hyperbola. So, this might be something like this, intersecting with maybe something like this, just as an example. And we are looking for the points of intersection. Okay, but let's see how it actually goes down. We will either do substitution or elimination whenever we do these problems. A problem like this, best to do elimination. So we are looking for opposites that will cancel out. This problem was a little bit extra easy because, for example, if you look at the y squared terms, those are already opposites that cancel. Okay, so we can just go ahead. And look at those y terms as well. Positive 54y, negative 54y. We already have opposites that cancel. So if we just combine like terms vertically between these two equations, these are going to cancel out. Okay, sometimes we have to multiply it by a -1 or something, but this was extra easy because they are already opposites. So, like terms, like terms. So I'm just combining all like terms here. 2x squared has no like terms that go with it, so I'm just going to leave that as 2x squared. X and negative 7x make negative 6x when you put those together. 75 and negative 111, that's negative 36, and of course 0 and 0 make 0. So far we have this. There's no reason not to divide everything through by -2 just to make the numbers a little bit easier to deal with. So that's what I'm going to do. Just divide everything through by -2. By 2. So that's going to give me x squared minus 3x minus 18 is equal to 0. This equation only has x's, so I should be able to solve this. Okay, let's solve by factoring. X squared can only be x times x. 18, alright, first thing that comes to my mind is 3 times 6. Okay, I could have done 2 times 9, but now I need to look for the negative 3x. Inner, I have 3x. Outer, I have 6x. To make a -3, I need a positive 3x and a negative 6x. So that means this will be positive and this will be negative. Also, 3 times -6 is -18, so that works out as well. So we factored it. Now to solve it, we need to set each of these factors equal to 0. So we need to set x plus 3 equal to 0 and x minus 6 equals 0. This will give me x equals -3 and x equals positive 6. Now, in the back of your mind, you should be thinking, fine, we have these x values, but we need the y values that go with them. So right now we've got -3, that's an x value, and we've got positive 6, that's an x value. But -3 comma what? 6 comma what? We need to find the y values. The way we will find the y values is by plugging these x values back into one of the original equations. The top equation is a little shorter, so that's the one I'm going to use. Okay, I think I will change colors for this. So let x equal -3. Alright, that just means I'm substituting in -3 and I'm going to see what happens. So now I have 9y squared plus -3. Okay, that's the x right there. Plus 54y plus 75 is equal to 0. So this is 9y squared. So like terms, negative 3 and 75, that's 72. So I have 9y squared plus 54y plus 72 is equal to 0. I'm noticing that all three of these are divisible by 9. So there's no reason not to divide everything by 9. So I'm just going to divide everything through by 9 and just make the numbers a little bit more friendly, because why not? Friendlier is always better. So I'll have y squared 6y plus 8 is equal to 0. Okay, so now I can solve this by factoring. So y squared will be y times y. 8 is going to be 2 times 4. And if I just let both of these be positive, 2y and 4y gives me 6y, so that works out as well. So I need to set both of these equal to 0. So y plus 2 equals 0 and y plus 4 equals 0. That gives me y equals negative 2 and y equals negative 4. Okay, I'm just going to put a circle around these for a second. So, both of these y values came from the single x value of negative 3. So I will definitely have negative 3 comma negative 2. But I also have to add on here negative 3 comma negative 4. I have to repeat the negative 3 because I need 1 for each of these y values. Both of these go with negative 3. Okay, so far I have these three solutions. But I still need to find the y value that goes with an x value of 6. So I think I will change colors one more time. Okay, so this time I'm going to let x equal 6. Alright, so that's going to be the same thing I had before, but instead of a negative 3, I'll have a 6 right there. So this is going to be 9y squared plus 6 plus 54y plus 75 is equal to 0. 75 plus 6 is 81. So this will become 9y squared plus 54y plus 81 is equal to 0. Once again, I'm noticing that all three of these numbers are divisible by 9. So I might as well divide everything by 9 just to make the numbers a little bit friendlier. Okay, so that's going to give me y squared plus 6y plus 9 is equal to 0. Let's go ahead and solve this by factoring. Y squared will be y times y. 9 is going to be 3 times 3. And I can just leave them both positive because 3y and 3y make 6y. Setting these equal to 0, I have y plus 3 equals 0. And I really don't need to write this twice because they are identical. So either way, I'm going to get y equals negative 3. Okay, so when x is equal to 6, y is equal to negative 3. So that means I have the point 6 comma negative 3. So these 3 points represent the intersection between the parabola and the hyperbola. Alright, so this is the solution set right here. Let's do one more, but this time we're going to use substitution. So a problem like this is perfect for substitution, because notice that part of this equation is the same for both equations. Both equations have x plus 5 squared in it. So we should be able to do a nice little substitution there. So what I like to do is I like to write the equations side by side right from the beginning. So I have my 6 times y plus 3. You see, I'm going to plug this in. You know what? I think I'm just going to write it in order. So my first equation is x plus 5 squared plus y minus 1 squared is equal to 16. Okay, I'm drawing the line here. In my second equation, I have 6 times y plus 3. You know what? I feel like I should do this in another color. So my second equation, I will have 6 times y plus 3 is equal to x plus 5 squared. Okay, so here's what I'm going to do. Because x plus 5 squared is the same in both equations, I can do a substitution here. Okay, so I should be able to take the 6 times y plus 3 and substitute that in the other equation, because x plus 5 squared equals 6 times y plus 3. So I should be able to do that replacement, that substitution. So that's what I'm going to do. So instead of x plus 5 squared, I'm going to write 6 times y plus 3 in its place. Okay, and I still have the rest of this equation. Y minus 1 squared is equal to 16. This equation has only y's in it, so I should be able to solve this if I'm very careful. So this will be 6y plus 18. Okay, this I have to do y minus 1 times y minus 1. Okay, so I'm going to have 6y plus 18. That's an 8. And if I multiply all this out, I'm going to have y squared minus 2y plus 1 is equal to 16. So just combining my like terms, I'm going to have y squared. But then I have 6y minus 2y, so that is 4y. 18 plus 1, that's 19, is equal to 16. I need to solve this. I need 0 over here, so I'm going to definitely subtract 16 from both sides. So that's going to give me y squared plus 4y plus 3 is equal to 0. Let's solve by factoring. So this will be y plus 1 times y plus 3. Okay, that's how this factors down. In order to solve it, I need to set these equal to 0. So y plus 1 equals 0, and y plus 3 equals 0. This will give me y equals negative 1, and this will give me y equals negative 3. Okay, so these are y values. So what I have so far is something, comma, negative 1, and something, comma, negative 3. I have these y values, but I need to find the x values that go with them. So how will I find those x values? Well, I will take these y values and I will substitute them back in to the other equation. Okay, we already used this equation on the left. So one of the reasons why I write these side by side is to make it more obvious that I've used this equation. Now it's time to use the other equation. So Okay, so the first thing I'm going to do is I will let y equal -1. Okay, I'm going to let y equal -1, and I'm going to see what happens. So this is going to be 6 times -1 plus 3 is equal to x plus 5 squared. So this is going to be 6 times 2 is equal to x plus 5 squared. So, of course, I'm going to have 12 is equal to x plus 5 squared. Taking the square root of both sides, I will have plus or minus radical 12 is equal to x plus 5. Don't forget your plus or minus whenever you take the square root of both sides. Now, I need to do two things, and I'm going to do them both at once. First of all, I need to subtract 5 from both sides to get x by itself. This -5 goes in the front before the plus or minus. So I'm going to have -5 plus or minus. But then also, the square root of 12 can be simplified. Because radical 12 is 12 is 4 times 3. So this will be 2 radical 3. So now I have -5 plus or minus 2 radical 3. Now this plus or minus means we really have two separate solutions. And remember, this is x equals. So this is really x equals -5 plus 2 radical 3, or x equals -5 minus 2 radical 3. That's the plus or minus happening. So I have two different solutions here. Okay, I'm just going to circle them real quick. Now remember, these two x values go with this one y value of -1. So remember right here where I said something comma -1? Well, that's going to be -5 plus 2 radical 3. Have to squeeze it in there. But because there's two of them, I'm going to have to do another y value of -1. So I also have another something comma -1. But this time it'll be -5 minus 2 radical 3. So we have two solutions so far. So that's what we get when we use a y value of -1. Now, what about a y value of -3? Time to change colors. So let us go back, and this time we will let y equal -3. Okay, so that's going to give us 6 times -3 plus 3. Alright, I'm just recopying this, but instead of -1, I'm putting a -3. Equals x plus 5 squared. So -3 plus 3 is 0. So this is 6 times 0 is equal to x plus 5 squared. So that just means we have 0 is equal to x plus 5 squared. Taking the square root of both sides, we get 0 is equal to x plus 5. Since the square root of 0 is just 0. Subtracting 5 from both sides, we have -5 is equal to x. Or we usually would write it in this order, x equals -5. Okay, so when the y value is -3, the x value is -5. So that means we have -5 comma -3. So these are the three solutions to the system. Okay, so that is it for problem number 11. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.